and gRPC has support via gRPC web, with time permitting, I'll give you a demo of at the end. REST has very loose contracts, so if you imagine you just send a blob of JSON at this endpoint, and if it's got a few extra members, nobody really cares. It just ignores those, or if it's missing sometimes you can get away with that as well. gRPC, on the other hand, has very strict contracts. Everything must be exactly where it expects to be, otherwise it just won't work. JSON is human readable, but the tooling around gRPC is becoming a lot better. So tools like Postman will decode the binary serialization for you, so you can actually see what is passing over the wire. And if you're doing massive payloads, then REST is probably better than gRPC. Okay, now let's compare gRPC and GraphQL. So that'd be another contender if you wanted to set up some interfaces for whatever application you're working on. So both of these, they're both released around about the same time. They've both got advantages over REST, and they both use an interface definition language, so different ones. And they're both open source, and they publish a single endpoint. Now, to compare them, so this is how they do things differently. gRPC is only HTTP2, and with GraphQL it's transport agnostic, but mostly over HTTP. gRPC uses protobuf, which is a smaller packet size and faster serialization, whereas GraphQL only uses JSON. So gRPC wins the performance battle. With gRPC, you can only use a single method at a time, whereas with GraphQL, you can say, well, I want the order, and then I want all the bits that make up the order at the same time. Whereas GraphQL, you have to define, well, I want an interface that says an order and the parts, and I can't change my mind dynamically on the fly. With gRPC, obviously, then you get stronger coupling because you've got to find all the methods up front, and you can't ad-lib as you can with GraphQL. With GraphQL, you've got weaker coupling. With GraphQL, you've got one-way streaming, and with gRPC, you've got key use case of two-way streaming. So it opens a pipe between two systems, and it can bang data to and from. So the latency with these exchanges is much lower. So again, if you care about performance and in two-way streaming, then gRPC is the winner there. So there's lots of articles, gRPC, the GraphQL killer, gRPC, the REST killer. That's not quite true. They all still have different use cases. So think carefully about which one you're selecting for your particular application. gRPC doesn't work well with caching. It does work well with caching with GraphQL because it's all posting. You need to do some additional setup to get it to do caching properly. Okay, so now we're going to give you a small code demo. We're going to do our first hello world. So I'm going to do a new project. And I have the gRPC ASP.NET Core service loaded. So I just start a new service called that, the same place, .NET 8, just accept the defaults. Crank, whir. Okay, so what do you get? So you've used the template, and it's put in some dependencies for you. I wish I could make this a bit bigger. I will read everything out so you can see it. So you've got 3 NuGet packages installed for you. So the protocol buff, so that's the serialization standard it uses for you, and the tooling. So I'm going to demonstrate what the tooling gives you in a moment. Then it's set up this template protofile. So the protofile is just a text package. So we say whether we're using protocol version 2 or version 3, we can define a namespace if we want. And then we say this maps to a greeter service, and it's got a remote procedure call called say hello, which takes a hello request object and returns a hello reply object. The hello request object is made up of a single parameter called name, and the hello reply parameter is made up of a single field called message. So it's also created this backing service here. So this is the greeter service. So when someone calls RPC, say hello, so I'm going to make this bigger for you. There you go. Is that better? Yeah, okay. If you can't see stuff, please shout and don't suffer in silence. So it creates this backing service here. So at the moment, there's nothing there apart from some logging. And then if we do a quick build on that, and then just show all the files. So what we've got here, so this text file is created into this beautifully attractive code here. So this is what the tooling's doing for you. So this is setting up the plumbing where you can call these endpoints for you. So that's all generated by the tooling. You don't need to understand this. I'm just showing you for interest that it's there. And final thing to know is that you're mapping a gRPC service in the program.build and you're adding gRPC. And that's all you need to get going. Oh, thank you, AVG. But we'll now play some music while AVG thinks about it.
Suspicious to send them data about in and out.
About 45 minutes. Okay. So eventually this will publish an endpoint on localhost. Hurrah, it's done that. There you go. Here, 5126. So we're just going to go to Postman and see if we can call that endpoint. So I'm going to go new. So Postman here helps you. So it's got a template 5126 on port 5126. And then we need to select method. So we're just going to import the protofile to do that. Oh, and here's one I did earlier. That's not actually the one I'm doing though. Okay. So this has got a say hello method. And I'm just going to compose. There you go. So it's replied with hello, John. All good. There you go. So that was literally set up in a few seconds. So I'm in the wrong Visual Studio. And then it called this web service here. So we needed to tell Postman what the schema looked like so it knew how to call out, and we did that by providing it with the proto file. Any questions so far? There you go. Hi.
Would you tend to actually, would the proto file be a thing you gave to customers, sort of thing? Like, I forget the Swagger sort of equivalent.
Yeah, I don't see why not. I mean, it doesn't contain any secrets and it's all human readable. And it is the source of all gRPC. So if you're doing it in Go, in Rust, in C++, it takes the proto file and transpiles that into something that C Sharp, Go, Rust can understand. So it's kind of like the common point that all of the different interfaces can talk to. Yeah?
Do you need to rely on that protofile, or can you
Yes.
dynamically find the schema for that endpoint? So for
No, so gRPC is very much static schema. You can't change it on the fly.
No, I mean, as in, can you poke the endpoint to get the schema without having the protofile?
I believe you can, yes. I haven't done that in this case, though. Yeah, in the project I had, we defined two services, and they're both in the same factory, so they needed We just had access to the proto files all the time. Yep.
You mentioned if you were using or comparing this with REST, if it was a large payload to use REST.
Yes. Yeah, if you're passing large image files.
What size are we talking about regarding the payload?
There is someone who's done the stats on that. That's not something I particularly looked at, but there's plenty of people who've experimented with that on the internet. So they maybe give you a more definite figure.
Right.
This is just sort of rules of thumb.
Okay, thank you.
Yeah.
So from my point of view, we tend to use a lot of Azure functions. So I'm wondering how this fits into that area.
Yeah, so it's published over HTTP. It should be able to use it on an Azure function as well.
Okay.
Yeah.
They have the templates all built in already, or this?
Well, the template gives you the tooling, so you probably need to add the tooling in manually to an Azure function. So you start off with a basic Azure function and then just add in the proto buff bit. This is just so you can get going with the hello world really quickly.
Yeah, I appreciate that.
Okay, let me crack on. So going back to the proto file, you've got a namespace, so you need to tell it about the namespace. That's something that's very C# specific. In the messages, it relies on what's called an ordinal, so it gives it a number. So that's in the first place, and if you define another column, you need to give it ordinal 2 or 3 and just keep incrementing that. You can use reserved keywords. So when a field becomes no longer used, but you've still got clients who are using that field, you can't just delete that field out. You need to keep it reserved because it will break everything. And there's optional keyword as well. So some parameters that are in fact optional. And you've got arrays supported through the repeated keyword.
Sorry, John, does that apply on the message as well? So you can have multiple messages being returned?
I don't know why you'd have multiple messages. You'd just have. Do you mean multiple messages of the same type?
Well, in the request, you've got string name equals 1. So if address was equal to 2.
Yeah. So I could do so string address equals 2.
You could have a mishmash of different messages coming back.
Yeah, and you can have complex objects, graphs of objects, arrays, whatever you need. Usual programming stuff. Okay, so now I'm going to do a client. So we interacted with it using Postman. I'm just going to create a new console application. There you go. Next. Great. And here I'm going to cheat a little bit. Or wasn't going to show you that. Right, so first thing I'm going to do is add a reference to my gRPC service so it understands the schema. So I'm going to do a service reference, select gRPC, and then browse to the file. Okay, crank, whir. So as you can see there, it's installing the NuGet packages I need. Just install one more NuGet package, which is bogus. I'm just having to use this for generating some data with. I'm having to use this for all my testing applications to create meaningful test data. Don't worry, the errors will go away shortly. Oh, I didn't mean that. Okay, right. So talking through the console application. So we've now got we've got a service published over here and a console application to talk between the two. What you've done when you added the service reference in, you got the same packages that we got when you start up the stub service project. So you've got the tooling and you've got Google protobuf. So you can understand the data that's been sent across the wire. So I just need to change the port number in here. 5126. Yeah, should be in a config file. Never mind, eh? And then we'll start both of them up again. Now, if the port number is correct, we should be golden. If we're not, we'll see some errors.
Meant to be HTTPS because you started with a HTTP server?
Yeah, I suspect I'm going to come unstuck. Is this AVG blocking it again? You are protected. Yeah, I know, but let my program run. Okay, we'll just quickly go through the code. So in the client, we say we get a gRPC client, and then I give it the port number to run on. So we just create for address a channel, pass that to the client code that's generated behind the scenes. So again, if I looked in the object directory, I'd get some beautiful machine-generated code that would allow the caller to send messages to the service. And then we'll just run through this loop. So you get hello request. So again, because we've done a service reference, it knows, this is the beautiful code I was talking about, but there is a string with message on it, and then you just a name, and then you pass. So bogus generates a full name. So we're passing a different name with each request. And then we get the reply from the service and then wait 1,000 milliseconds. And we just keep doing that. Right, let's see if we got an answer. No, we didn't get an answer.
I think you said it was HTTP, but your clients were talking to HTTPS.
Sorry?
I think your server was set up with HTTP only. Your clients are trying to talk to HTTPS.
Yes, but if that were the case, then we should have got an error message. I agree completely with what you're saying. However, a blank screen doesn't indicate anything actually took place. Yes, right. So now you're absolutely correct. This is where we need to change it to.
There we go.
Right, okay, so the HTTP port is 7046. 7040. Did I get that right? Yes, right. Okay. There you go. So I'm passing off all this names, and then it's replying with hello, whatever name I'm calling. So there you go. Within 20 minutes, we set up a service that hosts gRPC and a client, and we use service reference to automate some of the calling code behind the scenes. Any questions? Cool.
What happens on the client side if the server goes down? Is it just a
Well,
connection error?
that's where you would put in your redundancy code that would capture the exceptions the service was throwing and handle them in a safe manner.
Oh, no, there's no server.
Yeah, if it times out, presumably it'd throw an exception. That'd be obviously phase 2 of writing this code. Okay, so I'm just going to make my code a little more complicated. So I've now got a greeter service that takes a more complicated hello request option, takes a name in the first ordinal, a hello type in the second ordinal, which is an enum. We brought in this new complicated structure called a timestamp, which we've imported from Google Protobuf. And then we've said, don't use 4 to 6 because we need them for the future. And then we've got hello reply, where in first place there's a message and what visitor number you were. Oh, and here we define the hello num. Then behind the scenes, we're just going to modify our greeter service a little so it does something more funky. So it's red squiggles on visitor number because it's looking at the backing code that I haven't compiled yet. The tooling has now created the backing code, so red squiggles goes away. Okay, so we've got a visitor number here that's a static, and then gets incremented every time someone visits. And then we just log some information saying, hello, visitor number from Joe blogs at this date with the type of hello you're doing, and just log it out to the console. Okay, so that's the server code. And then we've got a slightly more complex client code. Hang on, 7040. Now you're saying, look, get hello request, but it's got all these additional types. How did it know about the additional types? Well, when we press compile, all of the code in both projects was changed with all additional information from the proto file. So it was immediately updated with the new data it needed to send across, and the types and the enum. So it knows about the enum now. That's not defined in the client project, it's just defined in the service. So yeah, the only thing I would note is that dates have to be in UTC. If it's not in UTC, it knows somehow, and it will throw a nasty exception. And then it needs to be in a specific format. It's a version of timestamp.
Good old binary symbolization.
Yeah. Right, so here we're saying something across the name and the hello type, whether it's a strong, medium, or weak hello, and it's all being logged to the service. So I think the point of this is you could be productive really quickly if you want to go for your low latency communications, and the tooling is really helping you here.
You just need to sell it to Lionel Richie now.
Sorry?
You need to sell it to Lionel Richie.
Okay. Yeah. Yeah.
Immediately say hello.
Okay, so we've got some slides to go through now. Probably covered most of this. Yeah, so we went through the proto file. We had some things to put in startup to say this is a gRPC project. We did a Postman example of that. We use JSON, even though it's not being JSON, it's in a nice JSON format, so people have a standard of entering it. And you use Postman or gRPC curl, plenty of tooling in this. So protobufs allow you to find lots of different types in its interface definition language, strings, floats, lots of different ints. There's a full list there. You can also import different types from different projects. So you can split your proto files up and you just import them via the import statement. And we had an example where we imported a timestamp from Google. Field numbers must be unique. You can't reuse field numbers. Then we had a console project. We just went through the packages we had to install. If we didn't do a service reference, but we did a service reference, so that set up all the code for us. Added in a bit of client code, and then did a method call from the client code. So there's loads of ways you can extend the basic service using timestamps, enums, reserve, optional, empty, streaming, and authentication. So streaming and authentication I'm going to go through now.
That project, how's this compared to like MQTT?
You'll have to ask the guy who's doing the MQTT presentation. Yeah, not something I've done much with.
The only real difference insofar as this is like a single endpoint, single channel, while MQTT more multi-channel.
Yeah.
Okay.
Yeah. So you're probably wondering, well, how do I pass no parameters? So you use the empty keyword here, or if I pass nothing back, again, or your function is void, then you pass empty back. So here we've got a data logger application, which is similar to the thing I was implementing for my IoT client. So we're submitting readings. We've got one method for that, and we submit a stream of readings. So here we're using the stream keyword, sending reading requests, and also returns a stream of success responses. So here we've got our single method, and here we've got a streaming to and from. So this is where you get the killer use case, and it streams messages via a persistent pipe. And we also demonstrate how to do authentication. So you send in a token request and receive a token response. So reading request, so got a meter name, temperature, humidity, pressure, usual stuff, timestamp when the meeting reading was taken, and then you're responding whether it's success and any message that it wants to send back. Set up all the backing code for that, and we've got a telemetry service. So there's a few extra things in here. So this just says all of these entry points must be authorized. And we pass in a few services. And here we're just, without doing anything with the reading, it takes in the reading request, just logs it out, and then passes success response back. Here, go through the stream case separately, I think. Right, okay, so this is the client. So we're just waiting a while for the service to start. We'll get a client in the same way as we did before. Hopefully it'll be on a port number we've agreed beforehand, and then we're not using the stream, so this is the single request. So we get a generator, and it just generates a new reading. You can imagine a random number generator running furiously away in the background to get that, and then we just call the endpoint. Okay. Right, so this is my client, and it's sending all this telemetry to the server, and the server's logging it out here, and it's, the client responds, everything was good, I received the message, okay. So as you can see, quite a slow progress through the system. Now, going back to our streaming use case, so we prepend the stream keyword on the request and the response. If we look at the backing service here, you've got an iAsync stream reader of reading requests, and then an iServer stream writer of response services. So while I've got data to look at, get the current reading, log it out, and then write a response to the end stream. At some point, the client needs to start processing those responses that have been put in the pipe for it. Work out.
Is that cache waiting for the client to take the response, or is it just streaming out regardless whether the client's there or not?
It's waiting for the client to pick it up.
So the client disconnected and reconnected, then it wouldn't lose any connection.
No, there's a persistent connection. It's just you can't send and receive at the same time. So here, again, just getting a gRPC client, and and then I will create 10 readings right into the stream, and then complete on the stream, and then read anything that's in the response stream. So you should see lots more activity there. There's my server on the right-hand side. Here's my client about to launch into life. So bang, 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 bang. And then there's all the responses that have been sat in the queue. Okay. Streaming, yes. So quick word about authentication. Yes, you can do authentication on gRPC. We have a really advanced JWT token validation service here that just tests if the password's correct and then returns success. And then you need to decorate all of the service with please authorize this. And then, of course, you've got to leave one method, authenticate method as allow anonymous, so you can actually call it. And then add in authentication in the program file. So just say you've got a JWT bearer and add authorization. Any questions? No? Pretty straightforward? Yeah, pretty straightforward. Yeah, read the docs. The docs are really good. Get a long way with that. Quick note on gRPC support. So you can do it on AWS and Azure, obviously. Probably on Google Cloud. Obviously, I've no experience with that. Note I'd say with Azure App Services, you need to set HTTP to 2, obviously, and an HTTP 2 proxy as on as well, and end-to-end encryption. Otherwise, it won't work. But they both support unary and streaming mode, so singular and streaming mode. Okay, so as an afterthought, we're going to cover calling from the web. This is a bit of a fudge, and you'll notice very quickly that the tooling is doing far less for you than what I've shown so far. So we're going to create a web client and talk through the npm packages. I've got a lovely PowerShell script that automates some of the steps you need to go through, and then going through the JavaScript file actually then it hooks into the tooling generated code. Okay, so on the server, we've got this isAlive endpoint. So that's what we're going to be calling. We're going to be calling the authentication endpoint as well. So if you have a look at that, so isAlive just says, you know, again, this is the name and a message response. We need to change the server because it won't understand what JavaScript's sending natively. So we need to add in another NuGet package. So this is the gRPC.asp.core.web package. And then in the server, you'll need to say to use it. Yeah, use gRPC web and enable gRPC web. And for various reasons, you need to allow cores as well. Add cores and use cores. Okay, so now I'm going to demo it for you because it makes a lot more sense demoing the final result first. Okay, so my name is Joshua. And I click send live. So then it went through an authenticating step. So that's calling the authenticating endpoint. It says I've received a token from the authenticating endpoint. I'm now calling the service with my new token, and the response I got from that service was, hello, Joshua. Okay, so now I'm going to talk through the code that sits behind that. So you've got a pretty basic HTML page with an input and a button. The code hangs off the button. There's this lovely code here that adds an event listener. So on click, it calls the service with this authenticated method, authenticates, and then gets the response. If it's valid, then it stores the token and calls the service with a bearer token, as you'd expect, and then gets a response. So that's the code I wrote. To get the gRPC interface, you need to install these npm packages here, grpc.just.js and protoloader and Google protobuf, as you'd expect. Right, this is where it really gets ugly. So I've managed, as I said, the tooling is doing far less for you here. So I've created this PowerShell script that steps through each of the steps. So for various reasons, you need to add the gRPC tools to the path. Otherwise, this won't work. But it's a path local to this PowerShell script. So it's not global for your session. Then remove any files that we removed before. Then create the proxy files. So here we're using protobuf executable, creating a JS file using in CommonJS output format, using this .proto file, the one I showed you before. Then you need to move them into a directory where they can actually get at them, delete any previous files there, and then use Webpack to build the files. And then they could be used by that send.js file that I demonstrated. And then it all works. Okay. So yeah, it feels like using gRPC over the web is a bit of an afterthought. In terms of the tooling, you need to work a lot harder, and I'm pretty sure it's less efficient because of all the gRPC web stuff you need to put into the server. gRPC is a standard, but with gRPC web, it understands it in a different way. So, yeah, who knows? Okay, so in summary, if you care about speed, you need to be thinking about gRPC. It's well supported across a huge range of languages. It's a way that a lot of vendors allow interoperability between different services written in different languages. One of the key use cases is streaming, so one-way streaming, two-way streaming. We can access it via gRPC web using a proxy, and it's well supported in the tooling with Visual Studio and Postman. There are some resources that I would recommend you use if you're interested in looking at that. The slides are on my slide share if you want to go have a look at that as well. Other than that, I'm finished. Any questions? I might make my train.
Are you saying it's not as useful for between web and the server? It's much more recommended for server-to-server communication?
I'm saying you have to work a lot harder. The tooling's not there as it is if you're just doing C# to C# or Go to Rust or, with web, you need to go through a proxy for the service to understand it. And I would imagine, though I haven't tested it, that there's a performance hit somewhere, either in terms of latency or throughput, because you have to go through the proxy.
So stick to Signal for now.
It depends what your use case is. Yeah, any more questions? Great. Feel free to connect on LinkedIn. Otherwise, enjoy the rest of your evening.
Cheers, John.
Okay.
Just quickly, apologies for those who came late. John has made the trek all the way from beyond Leeds, so he wanted to make sure that he was able to get home in good time. But thanks to Samson, the whole talk is on YouTube. So if you missed the start, you can catch up afterwards. So cheers for that, Samson. I just quickly need to say something that I've now forgotten.